Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is a friend from Ecosmob, Sagar Malam, Senior Project Manager at Ecosmob Technologies, which is a large system integrator based out of India and many other places, really. You're everywhere. And Sagar is a Kubernetes expert, and there's a few questions I want to ask him today. So welcome, Sagar, first of all.
Thank you, Luca. It's always a pleasure, and thank you for the introduction. And feeling very good to talk with you again. I think we met in the previous sessions, and right now we are again together.
Yeah. So before we get started, for a few people we haven't seen the previous episode, what's your? Could you give a quick introduction about yourself, please?
Yeah, sure. So, my name is Sagar Malam, and I am working as a senior project manager. I joined Ecosmob 10 years back as a senior support engineer, and since then, I have been working mostly on the telephony technologies like Freeswitch, Kamailio, and now I am also working with the Kubernetes, as well as I'm also managing the projects as a senior project manager.
Oh, nice. Well, then, I mean, Kubernetes is a hot topic right now. Everybody is switching. Everybody's trying to learn what the setup is, and it's effectively very important for RTC because it enables a lot of scenarios that are otherwise hard to manage. But I don't think people still very much understand what Kubernetes brings over Docker or other setups. So maybe before I ask you a few more specific questions, what's your main? So could you explain why you use Kubernetes? How long did it take to switch? Are you happy with it? All that. I mean, what's around your Kubernetes usage at Ecosmob?
Yeah, so I would like to describe which problems Kubernetes solved for us. Like before Kubernetes, we were using virtual machines on the cloud, and all of that was good. And of course, with Kubernetes, Kubernetes enables you to do automation, CI/CD, and all those advantages of Kubernetes. Everyone know. But I think the most important thing for us, and due to which we actually decided to go with Kubernetes, is control over rolling out the updates. So usually, you would have a single machine or a single virtual machine, and you would host all of your tenants. I'm giving you an example of a multi-tenant environment, a multi-tenant UCaaS platform. So to simplify, we can just take an example of just one virtual machine hosting all the tenants all together. And as the UCaaS service provider, you need to be innovative, and you need to keep on adding new features again and again, and very fast to stay in the competition. Now the problem that we are facing is that all the tenants were sharing the space, and if we want to roll out a new upgrade, we have to roll out for all the tenants together, or majority of them. And in case if something went wrong, let's say some kind of regression, it would impact the tenants which never wanted that particular upgrade at all. So with Kubernetes, actually, you get more control. Like what we did is that we created one pod which is capable to serve one tenant or the multiple tenants. And right now what we are doing is that we are putting the bunch of tenants in the same pod who has the same use case. So we have few tenants who are using call center services, few tenants who are using conference, some other tenants are they just want basic PBX, some other tenants they just want fax, for example. So we put the bunch of tenants in a particular pod, and that way we have lot of pods, and we have distributed tenants among them. So now when we want to roll out a particular feature, let's say that for example, in call center we want to roll out any new analytics report. Now I don't have to roll it out for all the tenants. Like only those tenants who are using call center, only they want them, and it matters to them only. So I would just upgrade the pod of that particular tenant, and I will leave all of the tenant as it is, and I will not touch them. And also we have a cases where there are some tenants which are huge, like they have 2,000 to 3,000 seats, and they use very
Wow.
basic services, and they don't like to get frequent upgrades. They are happy with the features that we have, and they just want stability. So if you are using same space for all the tenant, all of that is very very difficult to manage, because when you roll out, you will roll out for all the tenants. So that was the biggest problem. And and with the traditional architecture, like usually you need to have like very huge pipeline of QA and automation in order to make sure there is no regressions. But it is like really tough still, like it is almost impossible to like always roll out the upgrade without any regressions. Like a regression can be very small, but still it is possible. So we just wanted to go one step ahead, and we just wanted to have this kind of like architecture so that we can control whom we want to upgrade and when we want to upgrade, and we may decide to not upgrade the particular tenant at all in future. So that was the main reason, that was the requirement that came to us, and that's why we decided to like use Kubernetes, because like with Kubernetes, like spinning up pods and like managing all that infrastructure is very easy and fast, and best part of it is you can easily automate it. So that is the reason, and that's what we are that was the inspiration behind like choosing Kubernetes.
Yeah, it really sounds like, in general, what Kubernetes gives you is, I don't want to say it's only useful above a certain scale, but the trade off between the complexity and what you get from Kubernetes starts to really be good in favor of using Kubernetes when you're at the scale Ecosmob is. If you have multiple customers who have 3,000 users, then you need to be aware of, you cannot just restart the whole thing, right? It's while sometimes with smaller sizes or less distributed setups, what you do is, you know what, I'll just restart it when everybody is off the server and they won't even notice. But you can't do that when you have the scale you're at. So I feel like it's always a factor of scale. Then probably, so let me ask you this though. Before I have I have another question I want to ask you about the data plane and the control, because that's almost always the more complicated part. But first, for a developer, so say I am a developer, just I am myself, like let's take Luca. Luca is a programmer. I build applications. I know how to use Docker. I know some systems. I don't know how to use Kubernetes. Do I still work with Kubernetes on my local machine, or do I build the application using something else and then I bring it to Kubernetes? What's the developer workflow, not the production workflow?
Yeah, so like first of all, you need to learn the basic. Like you need to learn Docker. You need to understand how to create containers, and that should be the first step. And I think you can like after that, basically you can learn Kubernetes. And like in our case, for our developers, we actually use the micro KTS. So micro
Mhm.
KTS is the like minimal version which can run in Raspberry Pi
Oh,
or big servers. So what we are doing, that each and every developer has their own Kubernetes cluster, small Kubernetes cluster installed in their own computer, and they would just use their environment to develop. So yes, first step is that you need to learn Docker, and then you need to like convert your application into containers. And after that, the next step is to learn basics of Kubernetes. Like you should know how to like create a pod, how to tear down the pod, because majority of the deployments on the production environment, it is actually done by the separate team, DevOps team, who are actually experts in the Kubernetes. So for the developers, they need to know how to create Docker files and like Docker containers, and then they need to understand basics of Kubernetes CLI.
but so there's a micro. So what you'd probably start with the micro version of Kubernetes, so that your local development environment is the same as the production. Which sounds, yeah. I mean, it's.
Yeah.
I think I'll go take a look and go see how it works. Yeah. So in my experiments and when I was well, I can do some Kubernetes now, but I'm still a long way from being really useful. The most complicated problem I had is in general figuring out which data plane or which so how to control the cluster. And I feel like there's mostly because there's many options. Like it's other portions have only one thing, like use Helm, it's just Helm. Others are, there are components where you just use one thing, while in the data plane, so the control layer, first of all, if you can explain better what the data plane is, probably better. I know it's the control layer for the cluster, but maybe people, you know it better than I do. And second part is really just picking one. It feels like completely different domain, picking a front end JavaScript library. There's three or four, they're all good, and it's hard to say which one will be the best for you. So maybe we can start from there.
Yeah, sure. So like control plane, as all of you know, like it is, you can say it is the like engine of Kubernetes. It is where the Kubernetes stores all of its data, like the network topology, pods, DNS, and the IPs and everything basically.
Which
And
is not the networking layer, correct?
which is not networking layer. Like there is another layer, like we call it data plane. So in the data plane, like the applications interact with each other. So like RTP packets, TCP packets, SIP packets, all of those packets, they actually route through the data plane. And like there are several options for us with Kubernetes. Like the default one is kubeproxy with IP tables or IPVS, which you can use to implement the data plane. And there are some advanced plugins, for example, Calico, CNI. It is like something which I like and we have used. And also like Consul HashiCorp product is also quite good, but it is more designed for the service discovery rather than just to serve the purpose of like managing the data plane. So speaking about my experience with the data plane, like I think Calico is the best option because it is specifically designed for the networking and like controlling that particular layer. And good thing about is that Calico also supports BGP. So basically,
Oh yeah.
there is an overlay network and non-overlay network, right? And by default, like kubeproxy uses overlay network. Also, like Consul with Envoy proxy uses overlay network. But Calico is something which allows you to use non-overlay network, which is based on BGP. And you know that BGP is the de facto standard as far as like routing is concerned over the internet.
Yeah.
So we have used Calico, and it actually bypasses the overhead of like doing packet encapsulation, because like with that particular mode, you can basically run the Kubernetes cluster, I mean the networking, as a non overlay network, which means that each and every pod will be able to reach out to each other using the worker node IP. Like pod will not need to encapsulate the sorry not pod but the worker node will not require to encapsulate the pod's IP over the worker node IP and then send it out. So like it will be kind of peer to peer. Like pod will know where the other pod is located, and it can just reach out to that particular pod directly. So I think that like choosing the right CNI plugin is most important when you are building an RTC application on top of Kubernetes, because we are real time, right? So and there is a lot of RTP and like SIP packets which are going through the data plane, and you should try to avoid the overheads as much as possible. It's like using SRVIO for the virtual machines, instead of thereby actually bypassing the virtual layer of the networking. So we have tried to do similar, and I think with Calico in non-overlay network, I think you get the best results, and everything is like peer-to-peer. It's like two virtual machines interacting with each other directly, without anything in the between.
Yeah, yeah. So I think what's very interesting here is, and that's something that's probably underestimated, is the ability to have one single network connect all of your services, not just within the machine, but it works across servers. Is that correct?
Right, right. Yeah. So not just on the one worker node, but across the servers. And also like in Calico, you have an option, like you can selectively encapsulate the packets in case if you want to send it from one subnet to other subnet. So let's say that if you have a setup, like you have one Kubernetes cluster in data center one, and you have another Kubernetes cluster on another data center. So obviously, like the both data centers will not be able to communicate with each other unless you have some kind of like direct link between them. And in case if you don't have the direct link, like what Calico can do, it will like selectively pick the packets which are like going out to the other data center. It will encapsulate only those packets and send it through the overlay network. And the packets which are like within the same data center, like they will not be encapsulated, so they will be like sent out directly
That's
from like one worker node to another worker node. So like that is huge as far as like optimizing the network is concerned. and that's what enabled us to like use Kubernetes. Like that was the biggest problem for us, like how we are going to manage like networking bottlenecks. Like
It
that is the
really,
biggest problem for running
it
RTC application on top of
really sounds
Kubernetes.
like the ability to have one large network that encapsulates all of your services, whether there are in different data centers, etc., is alone a reason to use Kubernetes. Frankly, like
Yeah.
that's the running containers, running workloads, which are called pods in Kubernetes, or just running containers or whatever in Docker. It's not hard, right? In general, that's the easy part. Pretty much, they either start or they don't start, but they usually work once they're set up. But the networking part is really interesting. So you can build a full overlay network that encapsulates all of your services across clouds, for example. So you could have one data center that's in Google Cloud, one that could be in AWS, and they will all be part of the same network.
Right. Yeah.
That's very, very, very interesting. So why do you think Calico is the best, in particular for RTC applications? First of all, what are the problems with running RTC applications on Kubernetes? Because I'm, as someone who's been learning Kubernetes for a while. If you're running web applications, generally work. Like it's hard to not get a web server running in Kubernetes, or even if you have languages on the bottom, like Node applications, Rails application, usually works. But RTC, it's its own kind of worm. So first of all, what are the challenges in running an RTC real-time communication application on Kubernetes, and why do you think Calico is better than the others?
Yeah, so like the biggest challenge which I just explained, which is the like networking and the networking bottlenecks, and like one is Calico is a solution, of course, like because it is the best CNI plugin which like allows you to configure the network in such a way so that you can bypass most of the overheads. Second thing that we did to solve this networking problem is to try to put most of the traffic like outside of the Kubernetes cluster. Like TCP traffic is okay, like SIP traffic is TCP, and that can go to the Kubernetes cluster. But like most of the RTP traffic, which is I think majority of the traffic, stays on the SPC, and SPCs are like hosted on the virtual machines. They are not part of the Kubernetes. So that is the second thing. Like we are not like sending the RTP packets into the Kubernetes cluster as much as possible, unless like feature like MOH is required, MOH, or there is a like IVR. Only in that case we would like send the RTP packets to the Kubernetes, and it will be served by the pods. But otherwise, most of the RTP reeling will be like bypassing the Kubernetes cluster, and it will not basically flood the like Kubernetes at all. Uh, so I believe like Freeswitch and like Kamailio, OpenSIPS, all of them are quite compatible with the Kubernetes and similar kind of environment. And the biggest challenge is at the networking layer. Like personally, I have not faced any kind of specific challenge with Kubernetes. Like whatever challenges we have with virtual machines, that the similar challenge we also have with the Kubernetes. Like for example, uh, an RTC application is stateful, right? So you need to make sure that you actually send the like traffic, SIP traffic, to the same machine where it was there before, or you need to do some kind of like recovery on the other machines, and like share the state in that other machine. So all the kind of things we are already doing with the virtual machines, and I think we need to do same thing it is as well. So like for the horizontal scaling, like sharding, homing, and all those techniques that we use.
Nice, yeah. The main challenge. So let's step into one specific service. I often run things based on Freeswitch, right? Because it's where I come from. It's my main platform. And what are the challenge? If have you first of all, have you ever used Freeswitch on Kubernetes?
Yeah, of course. Like I am using FreeSwitch as the media engine.
And what are the things you should know to run Freeswitch specifically in Kubernetes? Because on Docker, you generally need to do host networking. Otherwise, you get the issue with the container taking an hour to start up, and the port ranges are usually the issue. But so the question is, what do I need to know to run Freeswitch in Kubernetes?
Yeah. So I think that because we are using Calico in non-overlay network, like a lot of the complication of maintaining ports, exposing the ports, all of that is solved, because pod is just like the like running a service just like any virtual machine will do. So like choosing Calico solves that problem. Now, second thing is that you need to set the limits, okay, for Freeswitch, because let's say like you need to reduce the overhead of threads, because when you are working with Kubernetes, like there has to be scheduling of each and every task. So you need to minimize the number of database connections, the max number of database connections that Freeswitch can make. You also need to minimize the number of event threads that can be created by Freeswitch. Like by default, Freeswitch would create the X number of event threads, and that formula is like number of cores divided by 2. So if you have 10 core worker node, then Freeswitch will create 10 worker thread, sorry, 5 worker threads for a particular pod. But that is okay with the virtual machine, but with pod you should not go with that. Like you should create one thread per pod. And also it depends like how many tenants you are actually hosting on that particular pod. Like if you have set up like me, where I'm hosting maximum 5 to 6 tenants per pod, in that case I would just allow one event thread per pod, and that event thread will be shared across all the tenants within that pod. So it's all about like defining the right limits depending on your requirements. So there is no easy answer for that. But apart from that, of course, like you need to make sure that you should not load unnecessary modules. You should like avoid to compile unnecessary modules to like minimize the size of the containers. Otherwise, it will directly impact on the RAM that is used by the pods when you start it up. So yeah, I think these two are the main points. Like first thing is the limits. Like you need to define the right limits. Like the limits may not be the same limits that you define for the virtual machines may not be like right for the pods. So you need to understand the use cases that you are going to run on that particular pod, and based on that you need to decide that. And second point is that try to like create the free switch binary with the minimal modules that are required, and avoid loading the modules which are not required at all. So yeah, these are the two main points in my opinion.
So that's super interesting to know that, as I mentioned earlier, the main problem with running Freeswitch and Docker is the networking. And so Calico takes care of setting up the port ranges without having the startup time issue, which is probably doing things in IP table space, not at the Docker level, which is
Yeah,
probably
yeah,
much
yeah,
more efficient.
yeah, right. So actually, Calico enables you to learn code at the uh, not at the, but it allows pods to use the network host, so that there is no Kubernetes layer. Like everything is like host
Oh,
network,
so
and
per
like
port, you can do host networking per port.
yeah,
That's insane.
right.
So some ports are bound on the host, and some others are not. That's awesome. Yeah, that's a reason alone to go play with Kubernetes and Calico. At least for me, because I do need to go get a couple of those things done for the signal wire for testing, and so it's really interesting. Well, I mean it's always a good starting point. Yeah, going back to the starting point. So you mentioned the name of the micro version of Kubernetes. Is it Kubernetes Micro? What's the name of the
So
project?
actually, I was talking about micro Kubernetes. It is a Kubernetes distribution by Canonical, the one who are also maintaining Ubuntu. So it comes up with the like minimal Kubernetes configuration and the plugins,
Oh,
which can like save a lot of time to like add those plugins by yourself. So like there are different options. Like there is Minikube, there is micro Kubernetes. There was one more. I don't remember the name, but I think that micro Kubernetes is the best option for us
I
because
once
it.
played with one that still lies, this K3S.
Yeah,
There's
K3
another.
is the another one. Yes, you're right. So that is something I have not played with. I tried Minikube and Micro K8s, and I like
So
Micro K8s more because it's so
MicroKDS is the
reliable.
recommended version.
Yeah,
Good. Well, then I guess I'll go try it right away. It's always a good. I feel like to me. So just a general remark on cloud deployments. There used to be much more focus on learning architecture on platforms like Amazon or Google. So you were a solutions architect for that platform, and you only knew the platform. Now a lot of focus is switched to, you don't really need to know how to use Amazon very much, AWS very precisely, right? Just to
Right.
know enough to stand up your cluster, and then it's all generic. Then maybe you want to use some specific services, like they have all the AI stuff now. So you want to run SageMaker, you learn how to do that, but you no longer need to know the ins and out of an AWS VPC really, unless you're doing something super specific because it's all in Kubernetes. Well, this is so networking question for you for Kubernetes. Say I need, so I have a customer, hypothetical customer, who has a private network, and they want to interconnect to my Kubernetes cluster using a private connection, like maybe a VPN. I don't know. Is that something that Kubernetes supports, or do I still need to do it at a machine level? I know this is sort of off topic, but since we're talking networking.
Yeah, yes, I think that's where overlay networks will come into the picture. Like you can still use Calico, and like you can create overlay network policy. So like whenever you need to send anything to the private network, which is I believe that it will be having its own subnet. So in that case, like this overlay network will like do the encapsulation of the packets, and that should work, in my opinion. I have never tried it, but I just presume that based on my experience.
Yeah, that will certainly work. Yeah, it's a. I mean, it's again. I feel like it's time for people. The time is right. The tools are there. Didn't used to be like that. Like even just 2 years ago, honestly, getting started in Kubernetes 2 years ago was much harder. Now you can get to something reasonably running quickly. Plus, from people I know, do you all run Kubernetes, let's say manually, or are you using any of the managed services? Because I hear, for example, that the Google Kubernetes engine is very, very good. Do you use
Yeah,
that, or
yeah.
you?
Yeah, right. Like so far, we have just used we have not used AWS or like Google Cloud, but we are having our own data center, and we have our own virtualization on top of that. But all this, like we are like keeping that in mind, because in near future we have to migrate to the Kubernetes, sorry, to the cloud like AWS or Google Cloud. So in that case, we are like picking the plugins in such a way that are supported by those services. Like for example, Calico is also supported by AWS, for example. And I think that like AWS uses Ubuntu, and it runs Kubernetes, its own Kubernetes EKS cluster service on top of Ubuntu. So that's why we decided to go with microKTS, because like I think mostly it should be compatible with each other. And ultimately, like in Kubernetes, everything is YAML file, right? So basically it's not like tough to like migrate in case required in future. But what I believe is that like at the current point of time, the like Kubernetes services provided by all the cloud service providers, they are not that much mature for the RTC applications. Like they are good for web HTTP, it will just work fine. But I think it will still take like 3 to 4 years for them to like do those advancements, so that we can run the Kubernetes RTC applications on top of that Kubernetes services. Because still there are a lot of things like at the networking layer, like we don't have a lot of control at the networking layer when it comes to like those service providers. Like we do have some control if we use VPC, but still like there are a lot of limitations, and without that it would be like tough to run an RTC application efficiently.
Definitely, yeah. Well, it's again, thank you so much. It's always a pleasure to get an expert talking about Kubernetes, because it's still a misunderstood topic. But I think with MicroKDis and the other tools that you suggested, it's a good starting point. And what I'm going to do is, I have a very small application that's composed of a Freeswitch server, a web app that's just one page, and a couple API endpoints. What I'm going to do is, I'm actually going to try and make it work on MicroKDis and see if I can get it to work, and then go from there. It's
Yeah.
so it's that sounds like, take something you already know works and make it into and get it to work in Kubernetes. It's probably a great way to learn it. It's That's where I'm going to start. Well, so I know someone from Ecosmob is coming to ClueCon in 2 weeks, right? So Rushi Brambat is joining us at ClueCon.
Yeah, yeah,
And
yeah, definitely.
well, maybe you can tune in, or looking forward to meet people from Ecosmob. It's always a fun time. So ClueCon is, for the few people that haven't heard yet, is in Chicago in 2 weeks from the 14th to the 17th of August. It's a fun event. We have a lot of interesting speakers, including Grushir Brombat from Ecosmob, and a lot of interesting technical topics. Many from the SingleWire team and other open source projects will be there, and it's always a fun time. Tickets are still available. You can probably also find a hotel fairly quickly. And if you're interested in joining us, it's gonna be fun. So Sagar, maybe next year. Who knows?
Yeah, definitely next year I'll be traveling there, and we'll have this call like sitting together.
Live, yeah, that will be fun. Perfect. So, well, again, Sagar Malam joining us today is the senior project manager at Ecosmob Technology, expert in Kubernetes, one of the few real experts I know, by the way. And so, if you need anything about Kubernetes, ask Sagar. His link is going to be in the description for the for the video. And well, thank you very much for joining us today, Sagar.
Thank you, Luca. It's absolute pleasure. Thank you very much.
And for the rest of the people, I'll see you next week. Bye.